Hey everybody, welcome to the Summer Activity 2 science lesson for the Knox County Schools Science Department. My name is Trudy Rogers and I'm one of the Knox County Schools Science Instructional Facilitators. I'm really excited that you're here today. Any of the activities and handouts that we use today can be found underneath the Student Resources tab on the Knox County Schools website. We're also really excited to see what you're doing with these lessons, and so please, once you get finished, tweet at KCS Science. Some tips for viewing this video: turn on closed caption if that is available to you. You can also adjust the playback speed to slow it down if that's helpful. You can watch the video in short clips, rewind, start over, watch it again. You can also ask somebody in your home to watch with you. You can stop frequently and talk with that partner about what you're hearing and what you understand. Today, we're going to be answering the question, how do you support a scientific claim with evidence? This question is important because our standard is engage in a scientific argument through graphing and translating data regarding human activity and climate. So we really want to think through, as we look at this scientific data, how can we build a really good scientific argument? And we're going to talk about how exactly to do that today. So you'll know that you're successful when you're able to use multiple pieces of evidence to support or refute, which means go against, a claim. So people argue all of the time. What exactly makes an argument scientific? Can you think of an argument that you've heard or been a part of recently? We had to get some food from the grocery store recently, and I wanted to make sure that my family bought ham instead of turkey at the grocery store. So I had an argument for that. I argued that ham simply tastes better than turkey, that it pairs better with cheese, that it looks better in a sandwich, and you might agree with me, you might not agree with me, and that's okay, but that was my argument. So trying to convince someone to think the same way that I'm thinking. The difference between an argument like that one and a scientific argument is that a scientific argument is based on data. So we are going to make a claim or have an idea that answers a question. So why is the sky blue is a question, and maybe we have some ideas about that and we can make a claim about it. But to make it scientific, we have to find some pieces of evidence that support what we are saying, which is our claim. And then we're going to explain any of the relevant science concepts that go along with that, so that whoever is listening to our argument can put it all together the same way we're putting it together in our minds. So let's think about an example. A question is, does fertilizer help bean plants grow? If you've ever looked at fertilizer with your family at the store, it's actually an expensive product. So is it worth buying it to add it to your plants, given that it costs a lot? So if I were going to grow bean plants at my house, or maybe I'm a farmer, I would want to know that it's really going to work before I spend my money on it. Well, here we can look at some data. If we take a look at this graph, we want to look at the title first. So looking at the title, N is the chemical symbol for nitrogen. You're going to be learning about the periodic table as you go through science, but N is for nitrogen, so this is nitrogen fertilizer, effect on pod, seed number, and yield. So I look down at the x-axis, which is here. And so I've got three different sets of bars. I've got pods per plant, seeds per pod, and the overall yield, which is how much the plant is producing. When I look at my y-axis here, this is going to be the number of each. So we can look at this, and in each set of data, the green bar is the tallest. When I look at the key, the green bar relates to the 90 kilograms of nitrogen, and when I look at my key, I see that 90 kilograms is the most of the three choices. So we have 0, no fertilizer, 45, and then 90. So I'm going to look at this graph and think about, what is it telling me? Well, We know that the green bar is the tallest, therefore we know that when we use 90 kilograms of fertilizer, that we're going to get more pods per plant, we're going to get more seeds per pod, and the plant overall is going to yield more, so it's going to grow better. So we can actually make the claim then that applying fertilizer to bean plants helps them grow better than without fertilizer, and we have data to support that. So we can explain that data and say that when bean plants receive 90 kilograms of fertilizer, they produce more pods and more beans per pod, as shown in the data. Fertilizer contains nutrients that plants need to build tissues, so that could be an important part of our argument so that people understand when they are listening to our claim and they're listening to our evidence what fertilizer actually is. So this would be a scientific argument. How is it different than trying to convince my family to buy ham instead of turkey? Well, it's different because we've made a claim. So we've said very specifically that applying fertilizer to bean plants is going to help them grow better than without fertilizer. And it's also a scientific argument because I have supported it with data and not simply my opinions. So my opinion on the ham sandwich was that it tastes better with cheese. Well, that's my own personal thought, and I don't have any data to back up that that's an actual real thing. So this is an example of a scientific argument. If you think about people who are using science to make claims, it's very important that they're using evidence to back up those claims. So some of you may have allergies. Some of you may know people in your family or your friends that also have allergies, and we take medicine sometimes to make ourselves feel better because of those allergies. They can make you feel pretty bad. So when we're choosing those medicines, we want to know that whoever has said that medicine works, that they actually have data to back up that claim, that they have evidence. So it's interesting that as we learn things like which allergy medicine is safe to take and which allergy medicine helps people the most, helps them feel better and have less symptoms, it is just as important to be able to disprove an idea or refute an idea or go against an idea as it is to be able to support it and be right. So in science, it's really interesting. It's one of the only subjects that ideas aren't really right or wrong. They are ideas, and then we build evidence to either support them or go against them, and either one is important. So it's all about the evidence. So as scientists, what we really are doing is trying to build strong arguments for or against an idea. So we don't like weak arguments. So a weak argument would mean that it doesn't have very much evidence. Would you choose one of these allergy medications to take if we only had one piece of evidence? If you only had one piece of evidence, your claim would be very weak, and probably not very many people would want to buy your medicine and take it. Scientific arguments look like this. We call this the claim, evidence, reasoning model. So in science, we often have questions, and those questions drive what we try to figure out and learn in science. And so a claim is an answer to one of those questions. We have evidence to support our claim, like we've talked about, and then reasoning connects all of those things together. So if we think back to our first question about will fertilizer help bean plants grow better, we made the claim that fertilizer, 90 kilograms of fertilizer, would make plants grow better, and we had specific data that helped support that claim. So we looked at our bar graph, and you can actually pause the video and rewind and take a look at that graph if you'd like. But we looked at how there were more beans per plant, more bean pods per plant, and more seeds or beans per pod. And we were able to list those things as piece of evidence. So when we look at the evidence, we want to be able to make sure that the evidence supports our claim. In the graph, when we were able to see the green bar showed that there were more bean pods per plant. That was a piece of evidence that supported the claim that fertilizer helped the plants grow better. And then we could also say that there were more seeds or beans per pod. And so that also supported the claim that the fertilizer helped the plants grow better. But we can't just stop there. We have to connect the pieces of evidence with each other and connect the pieces of evidence back to the claim. So we need to be able to explain that that graph and what we're listing as evidence supports the idea and how the two are connected to each other. And we call that our reasoning. So that explanation is our reasoning, and that makes a scientific argument. So claim, evidence, reasoning. We're going to practice a little. So here we have a data table, and in this data table we see that we've got depth in kilometers and temperature in degrees Celsius. The question that we're trying to answer is, how does the temperature change inside Earth as you move toward the center of the Earth? So we're starting up above on the top of the crust, and we're going to dig down, and as we go down in kilometers here in the data table, we're able to look at the measurements in degrees Celsius. So pause the video, take just a moment to review this data, and then look over here at your 3 choices of claims and choose the claim that's best supported by the data. If you chose claim number 3, then you're correct. The claim, the temperature gets hotter as you dig deeper into the earth, is definitely supported by the data. That's what the data is telling us. So we start here at 0 kilometers, and as we go down, as we get deeper into the earth, we see that the temperature continues to increase. So it goes from its lowest point to its highest point at the greatest depth. So that would be a good claim based on the data. What if we only had this one piece of evidence? Would this be a strong scientific argument? What could we do to make it even stronger? We could add more evidence. What if we could find some information that someone had written because they had data and evidence that they could point us to create their own scientific argument? So here we can read this little short piece of text, and they're going to give us more information that we can use to support our argument. Go ahead and pause the video now, read the text, and then we'll come back together. As we read this text, we see that they're talking about, could you possibly dig a hole all the way to the other side of the earth? Well, they list lots of reasons why that's impossible. They talk about the extreme heat, and they give us some specific measurements. They say that the center of the earth is between 5,000 and 7,000 degrees Celsius. I don't even know what that feels like. Can you imagine? It's pretty hot. They talk about the decay of radioactive elements adds additional heat. So they're giving us more information. And this is all something we can use for our argument. If we want our argument to be very strong, what if we consider who is writing this information? If it's a random person posting on a blog, that might not be strong enough for our argument. What if we found a piece of text that was written by a very well-respected scientist, or maybe a college professor, someone that's known to produce really good information, and their information is considered really good because they have built good scientific arguments, and the thing that makes them really good is that they use multiple pieces of evidence to support their claims, so they're not just making it up. So if you can find text that's written by a well-respected person or group of people, that's going to make your argument even stronger. So the result could look like this. Remember, our structure is claim, evidence, reasoning. Here, our claim is the temperature gets hotter as you dig deeper into the earth. Our evidence is at the surface, 0 kilometers, the temperature is 15 degrees Celsius. As you go down, the temperature increases about 30 degrees for every kilometer you go down. You could pause the video if you like, go back and look at that data table to verify what I'm saying. And then we want to provide our reasoning. So connecting it all together, we're going to explain that Earth's interior is really, really hot, 5,000 to 7,000 degrees Celsius in the center. Much of this heat is left over from the formation of the Earth, and radioactive elements also add to the heat. So we've explained some of those science concepts that help the reader or the listener understand our argument and understand our data. Now it's your turn. You are going to create your own scientific argument. You're going to have a few different pieces of data that you can analyze and interpret and add to your scientific argument. And I would love to see your final products. So really work hard on these. We're going to start out together and we're going to think about the question, what is causing the global average temperature on Earth to increase? So we're not thinking about, is the temperature on average increasing globally or not? That's not our question. Our question is, what's causing the increase? So we want to analyze the data with that question in mind and try to figure out the pattern in the data. What is the data telling us? And that's how we're going to decide what our claim is going to be. Remember, when we take a look at a graph, we want to start out by looking at the titles so that we understand what the graph is actually telling us. So here, our graph says separating human and natural influences on climate. So let's think about that for a moment. Separating human and natural influences on climate. What's a human influence on climate? How do we as humans influence global temperature and global climate? One thing that we do is we drive cars. As we drive cars around, we're burning gasoline and we're releasing that exhaust and gases back into the atmosphere that are helping create a temperature change globally. So we're doing that. What's a natural influence on climate? You may not know a lot about this just yet. Some of your teachers were able to get to these lessons before you left, and for some of you, this is all new information. So you can look in your online textbook for ideas if you like, but I'll give you one example. As I'm thinking about a natural influence on climate, I think about volcanoes. When volcanoes erupt, they too are releasing gases into the atmosphere that help trap the sun's energy close to the earth and warm things up. So driving cars is a human influence, and volcanic eruptions are a natural influence. When we look at the x-axis, we see that we're looking at years from 1900 to about the year 2000. And over here on the y-axis, global temperature change in degrees Fahrenheit. And then we also need to take a look at our key. So we are looking at observations of temperature. We're looking at natural and human factors together, and then natural factors only. So just separating those out on their own. When I take a look at this graph, I pretty quickly notice that the black line, the observations of temperature, and the purple shaded line of the natural and human factors together closely mirror each other. They look very much alike. What I do notice is that the green shaded line doesn't follow that same pattern. And so I can almost draw a straight line from the year 1900 all the way over here to the year 2000 and include all of that green shaded data so that those natural factors are pretty consistent over time. They stay the same. But the human influences, those human factors, those are changing. So if you think about what has changed since the year 1900 to now, when we think about those human factors, well, we are driving more cars. We know that in 1900, people weren't really driving cars around the way that we do today. We have airplanes now, helicopters, trains, lots of different things that are burning that fuel and releasing those gases, and other things as well, like factories. So we know that those things have increased. Nature hasn't really changed a lot. So we do see a little bit of variation in this line, but for the most part, it's very consistent or straight across. So looking at that information, I want to come over here and look at my choices. So these are ideas for you to think about in terms of what claim could you make based on this data. So take just a moment to read over these three, and then we'll pick one together. If you chose global temperature change is affected by natural and human factors, great job. So that would be a very good claim to make based on this data. Why are we making that claim? We're making that claim because as we look at the temperature change, the black line, we see that it is very closely mirrored by the line that's purple, natural and human factors. So we do believe that natural and human factors are changing global temperatures on average. So to make a strong scientific argument, remember, we want multiple pieces of evidence. So let's take a look at a couple more. This is included on your handout, so you can pause the video and take a look at it now, or you can look at it on your handout in just a moment. But here we're looking at the world population from 1950 to 2050. What year is it now? 2020. So when we're looking at 2050, these are projections or predictions. The years are reflected on the x-axis from 1950 to 2050, and on the y-axis the population in billions. So you can look at this data here, and you want to think about what patterns do you see. We definitely see an increase over time. What relationship does that have to the claim that we made? So remember, we said that our claim is that global temperatures are being affected by natural and human influences. And then you're going to have a second graph to look at. This is energy consumption in the United States. What does energy consumption mean? It means how much we're using. So this is energy use. And when we say energy, what do we mean? Well, if we look at our graph, we're talking about petroleum, which is oil, so burning oil, natural gas, coal, nuclear energy, other renewable forms, maybe solar energy or wind energy, hydroelectric. Hydro means water, so using water to make electricity at dams. We have those in East Tennessee. And then burning of wood. So when we look at over time, the energy consumption in the U.S. from 1776 to 2014, we see that some things stay nearly the same, like burning of wood. We have only a slight increase in hydroelectric power, but some of these things increase dramatically. So we want to think about the patterns we're seeing. We're seeing a lot more burning of oil, a lot more burning of natural gas and coal. So what relationship does that have to the claim that we're making? So think through those things, those ideas. And then you've been provided in your packet with this template for creating your scientific argument. Remember, we like to use the claim, evidence, reasoning structure. And here is the claim that we started out with. And you can actually reword this and make it your own, and then go through listing your evidence and then provide your reasoning, that explanation. In your handout, I've given you just a little bit of a reminder of the things we've talked about today, about what each of these things is. And then I've also provided you with sentence starters to think through how you might want to say it in your writing. So global temperature change is affected by natural and human factors. How can you reword that to make it your own? Here are some ideas. And then the evidence, what's that going to be? You're going to take a look at those three graphs and think about the patterns that you see and think about what you can pick out that supports the claim that we've made. If you pick out pieces of evidence that don't support the claim, what are you doing? You're making your argument weaker. We don't want weak arguments. We want strong arguments. So choose those pieces that best support the claim and then provide that explanation. Remember, your explanation is supposed to connect your evidence to the claim that you made and also explain how the evidence might relate to each other if you can do that. I'm really excited to see what you guys come up with. This has been the 7th grade Activity 2 Knox County Science lesson. Again, my name is Trudy Rogers, and I cannot wait to see what you guys come up with. And the only way I'm going to see it, or your teachers are going to see it, is if you email what you do, your scientific argument, to them, or tweet a picture of it to @KCS Science. I hope you're having a great summer, and we really look forward to seeing you again this fall. Have a good day.